Hey guys, welcome to Algos Explained. This is David Kim, and today we're going to be going over a question, um, we're going to go over an interview question. The question is when you're given an array of duplicates and there is one number that's not duplicated, go ahead and give me that number. And so what we'll do first here is we'll have our input is going to be an array of duplicate numbers, dupe numbers, and the output is going to be non-dupe number. Okay, cool. So here we're not going to worry about how many times it's duplicated, just as long as it does have a pair. But in our examples, we're just going to deal with one duplicate at a time. And so if your interviewer didn't give you an example, you might want to ask for one. And here's a very simple example that I can just think of. And your output is going to be 3 because 1's duplicated, 2's duplicated, but 3 is not. And so now there are many ways to do this question. I think the simplest way that probably would have come to my mind if I were in an interview situation would have been to store all of these in an object and make these numbers the keys. And every time you see one, we'll just the value will be the number of times you've seen it. And pretty much, if you do that, you'll create an object with a bunch of keys as the numbers. And when you see the one, we'll store the one. And when you see the one again somewhere in the array, whether it's the very next number or somewhere in the end, you'll increment that value by 1. So eventually you'll have an object with the key of 1 with the value of 2. Same thing with 2, you'll have the key of 2 with the value of 2. And you'll have a key of 1, or you'll have the key of 3 with the value of 1. And so if you use that strategy, you're going to have to go through the object one more time at the very end and then find out which of the keys has a value that is 1 and not 2 or any other even number if there were multiple duplicates. That if you want to, I think if you're in an interview situation and you thought of that right away, it's worth just saying it out like I did right now, because let's see. Well, first of all, you could already tell that the space complexity is not that good. You're creating a whole new object, and although it might be n over 2, nonetheless, it's going to be something bigger than. Actually, no, it's not going to be n over 2. Or, well, yes, it will be. And it might be better if there are multiple duplicates, but in the end, they might want something with constant space complexity. And so you already know that given this kind of question that you're going to have to at least have O of n time complexity, which means how, I'm not going to explain time complexity, but very simply, you're going to have to iterate through that. So it's going to have to be O of n. Space complexity, they might say they want constant space, and they probably are going to say that if you're given this question, because that it is possible. And so what we're going to do is I'm going to show you how I like to do it to achieve constant space complexity. I like to turn these numbers, or not turn them, but then use the XOR function. And so if you're not too familiar with it, I'm going to demonstrate it right now. If you are, you probably already know what I'm going to do. So thanks for checking this out. Okay, cool. So XOR is pretty much, it looks like the caret symbol, looks like the power symbol in like a calculator, but pretty much you have like a number here, you have a number here, and XOR is going to look at the binary representations of these numbers, and it's going to pretty much find which numbers are not equal. Just checking if my mic was on. So we need to see, if we're going to do this right here, we need to see what does the 3 look like in binary, what does the 4 look like in binary. And so the 3 in binary, it looks like this, which is the 1's place, the 2's place, and the 4's place. And the 4 is just going to take the 4 place. And so it's going to have, and then what XOR does is if it checks, are these equal? If it's not, the 1, if it is, then it would have done a 0, but all these are not equal. So that is what you're left with. And pretty much if you do this in the console or like in Node, what you're going to get is you're going to get this number, not in binary, you're going to get an actual number. This is 4, 5, 6, 7. And so you're going to get number 7. And so how this helps us is if you do a number XOR to itself, you're going to get 0. And I can show you right here real quick, because that is exactly what happens, and everything is going to be equal to each other, and that is 0. So you might already have the gist of what is going to happen here. We're going to XOR every number to itself, or to, we're going to hold a number, we're going to make it equal to the XOR, and then we're going to be left with, at the very end, one number. And that one number, we're only going to be left with one number because, as you can see, if you XOR a number to itself, it's going to cancel out. And so these ones will eventually cancel out, these twos will eventually cancel out, regardless of what order they are in. And so, but say you're not too familiar, you want to do the XOR, you want to understand it a little better, but you're not too sure about the binary. There is an easy way to find binary representations. You just have to do a number, so maybe like a 3.2 string, and as the argument, put a 2 in there. And so that will give you binary. And you can also do, let's see, you can also do 8 and 16. And this will give you octal and hexadecimal. Octal, decimal. Okay, in case you actually needed to see the binary representations or the octal or the hexadecimal representations, this is how you see it for yourself. But if you use XOR, you don't have to worry about turning it into binary. We just turned it into binary so that I could show you what is going on. But if you do 3 XOR 4, you're going to get 7. You're not going to have to worry about these numbers over here. And so let's go ahead and give ourselves a different example and start writing some code for it. Okay, cool. So we're going to give ourselves a little bit longer of an example. Let's say we're going to have a 5, 3, 1, 2, 7. That's too long. We're going to keep it to 3 duplicates. 3, 5, and 1. And so 2, that's our magic number. That's the guy that hasn't been duplicated. 5 duplicated, 3 duplicated, and the 1 has been duplicated. And to prove that these order doesn't matter, we separate it out like this. And so pretty much, let's go ahead and I'll stand over here. Let's start writing some of the code for it. And once we have the code written out, we will kind of run this through it to make sure that it works. And so we're going to be doing this in JavaScript. And so we're going to let find non-dupe, and it's going to take in an array. Hopefully the angle's good. I haven't gone this far back, but I don't know. We're going to hold on to a number, and we're going to set that to 0 for now. And that's going to be the number that constantly gets updated as we do the XOR. And so we're going to have to iterate through the array. So we're going to use a simple for loop. I is less than array.length. And I plus plus. Okay, cool. And so what we're going to have to do, and it might make more sense once we run through an example of it. But pretty much we're going to have the number. And we're going to have to set that equal to the number XOR the next number. Number XOR the next number, which is array of I. And so that will constantly update. And in the end, we're going to be left with one number. And that will be our non-duplicated number. And again, we can just return numbers straight out because we don't have to worry about some binary changes going on. Or it is doing binary changes in the background, but it's just staying as an integer for us. And so let's go ahead and really see what this is doing here. We'll start off with 0 because that's what happens here. We have num is 0, so the first line that happens here is we're resetting num to be 0 XOR 5 because that's the first place in the array that we're looking at. And so if 0 is at 5 is going to be 1 in the 4, nothing in the 2, and 1 in the 1s. And so we'll just add some more zeros in there for the sake of seeing the XOR clearly. that's different. Those are the same, and that's different. And so that is we're left with 101 now, which happens to be, this doesn't matter, but this is going to be a 5. And so now num is 5. And so now we did that. And now we do the 3, which is going to be 0, 1, 1. And so we XOR this guy, it is 0, 1, 1. And this looks like, what is that, 4, 2. So that looks like 6. And we don't even have a 6 in here, but that doesn't matter. This is just what is happening in our XOR. And so num is 6. And so now we do 6 XOR 1, which is going to be a 0 there, a 0 here, and a 1 here. I think I'm going to stand over here. And so this XOR is going to be a 1, 1, 1, which is a, what is that, 4, 5, 6, 7. That's going to be a 7. Again, this number doesn't really matter because in the end, what is equal to each other is going to cancel out, and we'll see that. But we did the 1 here, could X that out. And now num is 7, so 7 XOR the next one, which is a 2, 0, 1, 0. This guy is going to be 1, 0, 1. And so that looks like a 5. Aha, we're starting to see some of the numbers again. And so now num equals 5, so 5 XOR something, which we just did the 2, 5 XOR 3. So that is 0, 1, 1. So this is a 0, 1, 1. That looks like 6. And so num is 6, num XOR the next one, which is a 5, 1, 0, 1, which is a 1, 1, 0. And so that is going to be a 3. And so that was the 5. We just did the 5. And so now num is 3. 3 XOR 1. Let's see. 1, 0, 0, 1. That is going to be 0, 1, 0. And that is going to be 2. And 2 was the one that we were looking at. That's a 2. I X'd it out, but that's a 2. And we were looking for a 2 in the end. So pretty much after all of these XORs that happen, we're going to be getting back 2. And so that's how it works. If we had multiple duplicates, like say we had 2 5s in there, that wouldn't matter for us because as long as it has a pair, it'll end up XORing itself out because of the way XOR works. And as we saw, it doesn't matter if it escalated to different numbers, it'll soon cancel itself out because of the way XOR just works. And so hopefully that helped you out. If you ever get this problem, you're probably going to want to do XOR, and they might ask you about how it works. So it's a good idea to kind of understand how these binary things work and how, I guess how the binary computation of XOR works. That's pretty much it right here. So if you found this video useful, go ahead, like, comment, and subscribe, and check out my other playlists. Right now I'm uploading once a week, and so I don't have too many videos out there, but yeah, anyways, I'll catch you in the next one.